Good day to my friends and our ma'am. Today our group is going to present about the temperature monitoring system in a nuclear reactor. First of all, myself Kavin, and I'm going to present about what is a nuclear reactor. Nuclear reactors are the heart of a nuclear power plant. They contain and control nuclear chain reactions that produce heat through a physical process called nuclear fission. That heat is used to make steam that spins a turbine to create electricity. So next, I'm going to talk about how does a nuclear reactor works. A main job of a nuclear reactor is to house and control nuclear fission, where the atoms split and release energy. So a nuclear reactor uses uranium for as a nuclear fuel, and the uranium is processed into small ceramic pellets and stacked together. Typically, more than 200 of these rods are bundled together to form a fuel assembly. A reactor core is typically made up of a couple of hundred of assemblies depending on the power level. So the fuel rods are immersed in water, which acts as both a coolant and a moderator. And a moderator helps to slow down the neutrons produced by the fission to sustain the chain reaction. And finally, the heat created by the nuclear fission turns the water into steam, which spins a turbine to produce a carbon-free electricity. And this is how a nuclear reactor works. And the further part of our presentation on the characteristic of the transducers we used to do this project will be explained by my friends. Thank you.
The most common nuclear reactor used is the pressurized water reactor or PWR. The PWR uses water as a reactor coolant in the primary circuit and as a neutron moderator which slows the neutron and enables them to produce the chain reaction required to produce power. All nuclear power stations operate by producing large amounts of energy in the form of heat. Nuclear reactions produce significantly more heat from each kilogram of fuel than conventional chemical reactors. The heat generated by the reactor must be removed to provide steam to drive the turbines in exactly the same way as their chemical burning equivalents. Just like a conventional power station, failure to remove the excess heat results in dangerously high temperature which could lead to meltdown of the turbines. The figure shows a simplified schematic of a PWR power station. The containment building houses the major difference where a conventional boiler is replaced by a reactor. The heat generated by the reactor is controlled by special rod A which absorbs neutron and slows the nuclear reaction. A sealed primary circuit B contains water which is used to cool the reactor. The heat absorbed by the primary circuit is transferred to a secondary circuit C which delivers the heat in the form of superheated steam to drive the turbines coupled to the generators. Temperature measurement is vital to both the efficient and safe operation of the heat-powered system.
Okay, hello and assalamualaikum everyone. Today I would like to explain you guys one of the type of the transducer which is resistant temperature detectors, RTD transducer. Okay, RTD is a temperature sensor which measure temperature using the principle that the resistance of metal change with temperature. In practice, electrical current is transmitted through a piece of metal which is RTD element ataupun resistor that located in proximity to the area where temperature is to be measured. Resistance value of RTD element is then measured by an instrument. Resistance value is then correlated to temperature based upon the non-resistant characteristic of RTD element. So how RTD works? RTD works on basic correlation between metals and temperature. As the temperature of metal increases, the metal's resistance to the flow of electricity increases. Similarly, as the temperature of RTD resistant element increase, the electrical resistance measured in ohm also increase. So RTD are commonly specified according to their resistance in ohms at 0 degrees Celsius. The most common RTD specification is 100 ohm, which means that 0 degree Celsius, RTD element should demonstrate 100 ohm of resistance. Resistance increases as temperature increases. Change in resistance of material per unit change in temperature should be as large as possible. Sepatutnya change in resistance of material ni kena sebesar yang mungkin lah. So the temperature should have high value of resistivity to get required value in less space. Resistance and temperature relations should be continuous and stable. So example of resistive materials is platinum, nickel ion, tungsten, copper, but platinum is the best for large temperature range. It is due to high temperature, gain constant and for high stability. So, setiap transducer, each type of transducer have their advantage and disadvantage. So here are the advantage and disadvantage of RTD. So the advantages is stable reading, reliable, high accuracy, and better linearity than thermocouple and thermistor. But the disadvantages is it is very expensive, which is, for example, platinum. It need power source and small change in resistance because it need a bridge circuit. And lastly is subfitting. So that's all from me. And next is my friend will explain you guys next.
Good day to everyone. My name is Ravinesh. So I'm going to explain about thermistor today. Okay, what is thermistor? Thermistor is a resistor which indicates the change of temperature in a circuit or a system. Okay. It is made of metallic oxide pressed into a bead, disc or various shapes, and it comes out in orange color mostly. Okay. Next we talk about what is the working principle of a thermistor. The working principle of a thermistor is where the temperature rises, the resistance will decrease, and the current flow through the thermistor will increase, indicating that the temperature rise is occurring there in the system. If the temperature is decreasing, the resistance will increase and the current flow will decrease, which indicates there's a fall in the temperature of the system. Okay, so that's the basic principle, working principle of thermistor, which detected by the metallic oxide present in the thermistor. Okay, next upon we will talk about advantage and disadvantages of thermistor. Firstly, it is fast in measuring temperature change. Second, it's cheap compared to RTD. Third will be small and compact sizes, and it provides good accuracy data in a given range only. Disadvantage is limited temperature range, and resistant temperature is non-linear. Retrieving temperature data is also difficult due to the non-linear rate. And next will be can self-heat during process. Thank you.
Hi everyone. So now we will be looking into the key differences between RTD and thermistor. Knowing the key differences between them are crucial, as this knowledge will help you to be able to identify which type of transducer is more suitable for any specific requirement, which in our case is for temperature monitoring system in nuclear reactor. The first difference is that RTD is a type of instrument used for measuring temperature, while thermistor is the thermal resistor whose resistance changes with temperature. Next, RTD is made of metals having a positive temperature coefficient, for example, platinum and nickel, while thermistor is made of semiconductor materials, for example, silicon. Comparing accuracy. The accuracy of RTD is lower compared to thermistor. This is because, as we have learned previously, thermistor has negative temperature coefficient and is able to detect even the smallest change in temperature. RTD is less sensitive than thermistor. RTD is large as compared to thermistor. And the cost of thermistor at times can be much higher than RTD. Even though RTD uses platinum, which are expensive, many thermistor models come with extended temperature range, which often cost more than RTDs. Thermistor gives quick response than RTD. Thermistor is usually used to measure small range temperature, while RTD is used to measure higher range temperature. RTD characteristic graph is linear, while it's the opposite for the thermistor, where its characteristic graph is nonlinear. The resistivity of RTD is lesser than thermistor, and the hysteresis effect in thermistor is higher than RTD. And last but not least, RTDs are commonly used in industries for measuring high temperature, while thermistors are more usually used in home appliances where they only measure small temperatures. Now, moving on to the conclusion. We know that both RTD and thermistor are temperature sensing devices. The main difference lies in the temperature range. In short, thermistors are better for precision measurement, and RTDs are for temperature compensation and also for higher temperature range. Therefore, it can be said that the transducer which is more suitable for temperature monitoring system in a nuclear reactor will be RTD.